Hello everyone. I've been working with the Terraform MCP servers for a while now, so I thought I would share some demo how it will be useful for everyone to work very effectively. So today we'll be building a complete Terraform setup that generates Terraform code to deploy Azure infrastructure uh, in the Azure cloud. So we'll be utilizing Terraform MCP server for this. So basically MCP servers gives agents the context that they need to think in the right direction. We might already started using agents in the Visual Studio Code, but they are not that great. Sometimes they hallucinate or gives improper results. But if you add MCP server to work with your agents, then we can direct our agent to work in the correct direction. Before we go into the demo, let's go to Terraform MCP documentation and see the prerequisites. So basically, we need Docker before we install Terraform MCP server. And of course, we need Visual Studio Code or Cursor. So the setup is fairly simple. We should install Docker desktop in our system, and then we should have Cursor or Visual Studio Code in the agent mode. What do you mean by agent mode? We should be working with the agent mode. So let's go to the documentation. You can come to the documentation in the GitHub and click on install MCP server for VS Code. In the VS Code, we can actually see, so we can just install this MCP server, and it's going to appear in the configuration tools. So if you see here, you can see MCP server Terraform. To work in Cursor, basically you can create a .cursor folder. In that you can create mcp.json and then update this configuration. So it's basically provided here. So whenever you are trying to use the Terraform MCP server, it basically spins up a container in the Docker desktop. So we'll be working on a fairly simple architecture. We'll be hosting our application in Nginx, and the user will be first will be hitting the public IP of the application gateway, and then the application gateway will be forwarding the request to the virtual machines which are behind private subnet, which are not accessible through the internet. If you want to access into this box, you need to come from the public subnet. You need to log into the jump box, which has a public IP, and then we can SSH into this private virtual machines. If you think that we need internet access for this Nginx virtual machines, like for the updates, then that outbound connection will be done through the NAT gateway. So NAT gateway is responsible for giving internet access to the private virtual machine. So this is the architecture, and we are going to spin up this infrastructure using Terraform MCP server, which is basically hosted in our machine. And let's see how it goes. So I have already a prompt ready. Basically, I have prepared this prompt so that at, in the demo, the LLM doesn't hallucinate. So here we are going to give this prompt to our agent, and we are asking the agent to use a local MCP Terraform server to generate the Terraform code. The agent should follow all the best practices like reusable modules. They should have a clear dependencies and variables set, the tagging, and the meaningful output. So again, we are defining like we need a resource group in the central US and the storage account and container for storing our Terraform state file. This is nothing to do with our architecture, but we are creating this to store the file of our Terraform configuration. And we are going to create a virtual network which has a public subnet, private subnet, and another subnet for application gateway. And we're going to create a network security groups which allows traffic from application gateway to the backend VMs, and how you have to route our inbound SSH to the backend servers. And we are going to create two virtual machines basically, which will be hosting an Nginx web server in it, and we will be having one jump box. And finally, we are going to have an application gateway which has a public IP to it, so that we can able to access our web page in the Nginx. So we are asking to give a proper output as well in the output files. So this is pretty much it, and let's see. I'm going to select a model which doesn't think much because we already giving Terraform MCP server in the as a context. So before that, let's check whether our MCP server is ready. Let's go to cursor, and the MCP server configuration that we added needs to be enabled. So we can see the Terraform MCP server here. Let's go and enable it. Container is created for this. There are a lot of things that this Terraform MCP server can do. It can get latest module versions and get latest providers and modules and policies, and even it has development guide and Terraform style guide. So all these are very useful for our agent to have this context so it can work well. So let me copy our prompt and give it to the agent. I'm choosing the Claude 4.5 without thinking, so it doesn't need much thinking because we already providing Terraform CP server. So I don't know why it's not getting copied. Okay. This is the prompt that we are going to give to the cursor. Let's see what happens. So it took our prompt. Okay. Ask every time. So it's basically running our MCP tool. If you see here, now it want to search providers for each of the service. I'm going to say run everything. Yeah, continue. So it doesn't ask me the we can have some rules such as uh, project structure. Um, if you see if you're creating a Terraform files, you put it in the infra, and if you are creating application files, you can put it in the src folder and docs in the documentation folder. That's why it took this rule and applied while creating the files for us. Let's go to infra and modules folder and see what's been created. I can see it's still creating all the necessary files that are required. Now it is an application gateway module. Let's go and see how our resource group module looks like. It looks like this is for the state file, to store the state file, Terraform state file, which has some kind of error. Let's see if it's able to fix on its own. It's creating variables.tf, output.tf, backend.tf. Let me create a helper files for easier usage. Okay. It's creating tf I will let the agent do its job and we'll come back and see what's been created. Oh, nice. It's creating the git ignore file as well in case we want to push this code to repo. Yeah, looking pretty good. It's created variables as well, variable.tf, and these are the modules, and this is the main.tf file that actually creating all the resources. Okay, nice. So we are going to it's creating the resource group and backend storage for our state file to be stored. After that, it's creating a virtual network, and also we have a public subnet and private subnet in this, and application gateway subnet. So it took all the instruction and creating according to it. Yeah, and it's creating NSGs and the Nginx web servers. and the gem box and the application gateway. Looks like it's completed its task and creating architecture there. So we have all the modules here for the virtual network and virtual machines. We have main.tf, output.tf, and variable.tf. And also it created a cloud init template that needs to be running after the virtual machines are created so that the Nginx web server is installed in it. Nice. We have a network interface for web servers. It is internal, yeah. Yes. We don't want our virtual machines exposed to the public. And the only thing it couldn't able to get it right is the storage account name. But while running, I think it fixes. Just giving us a nice summary of what was done. Let's try to fix this. Yeah. Run Terraform init plan. So it's found some error in the backend address pool, and it changed. It's actually creating a SSH public key for me. So it's unable to determine my subscription ID, your subscription key, so that it will be authenticated with Azure. So it's asking us to do a login. Create searchable DF class. Okay, it's going to create a TF as well for us. Yes, this is what we need. Terraform command. It's running Terraform plan now. I think it's going to go through this time. We're running Terraform plan. So we don't have. So it understood we didn't create our SSH keys. So it's creating for us. Again, we are at Terraform plan. Nice. The plan was dot fine. It's creating all the necessary resources for us. It's time for Terraform apply. Terraform apply. Let's go to my Azure account and see 3, 4, 5, 6. I have 6 resource group right now. Okay, let's say yes. It's asking for approval to create all these resources. Yeah, we can see Uday-realm interviews. It's going to take some time create all the resources. Meanwhile, let's see what is the project summary it's created. Lines of code, our file structure, setup. So looking at the setup, we have modules created for all the resources, and we have one main.tf to define all the resources that we want to create in the Azure. Let's go and see. It's creating application gateway right now. Let's refresh our resource group and see what are the resources created till now. Let's do by type. We have public IP for Gmbox, public IP for app gateway, and we have network security group for web servers for the Gmbox, and network security group for app gateway. We have 3 NICs. One is for Web 0 and one is for Web 1, VM1, VM2. One is for Gmbox and NAT gateway for these 2 VMs to talk outside world. For the updates, we have 3 OS disks for each VM, and of course, application gateway. Let's wait till the Terraform apply is completed, and then we'll test our setup. There's a public IP. Okay. Let's see if we are able to get something. Nice. I think our setup is completed. Okay, yeah, we can see our setup is completed and apply is completed. 28 resources are created. App gateway, VMs, public IP, and storage account for state file and VMs and with the private IPs. Okay, the apply is completed. So it's asking us to visit this IP. So this request is going to web 0 and this request is going to web 1. That's pretty neat. That's cool actually. For the validation part, let's try SSH of our virtual box. Okay, I don't think it can. Yes, we are able to log into the gem box. Let's say yes. Nice. We are logged into the gem box. Let's ping our virtual machines. That itself says no. That's pretty much it. Almost took 20 to 30 minutes, I guess, for the agent to create all these files and create the infrastructure. That's pretty fast. So in this demo, we have created end-to-end demo from creating Terraform files to deploying into the Azure cloud within 30 to 35 minutes. So now we got a full Azure setup from writing Terraform files to deploying into the Azure cloud with the help of Terraform MCP server. What I love about this is like how flexible and private this setup is. You can basically have your own agent deployed in the Azure OpenAI or Azure AI Foundry. So there's nothing leaves out of this workspace, and you can do all these things without leaving any traces. So if you haven't tried MCP server yet, it's worth exploring. So that's pretty much for this demo. Hope you got some information out of it. Thank you for watching this. See you.